Alright, we are going to look at how to find the prime factors of some numbers. So the first one is 145. Just picked some numbers at random, so here we go. So we're finding the prime factors of 145. Find So this is also called finding the prime factorization, and what we want to do is break the number 145 down into prime numbers that if you multiply those prime numbers you would get the number 145 as the product. So we need to know some prime numbers, and we have that. 2 is the smallest prime number, 2, then 3, 5, 7, 11, 13, 17, 19, 23, 29, and so on. There are infinitely many prime numbers, but here are the first few of them, and we want to be able to break down these numbers like 145 into prime parts. So being systematic, we would start with the smallest prime number and see if we can divide 145 by 2. We can't because 145 is even, and we've got a rule that we know that is all even numbers are divisible by 2. So 2 is only a factor of a number, of a whole number, if that whole number is even, and 145 is odd, so 2 is out. So we'll check 3. The rule for being divisible by 3 is that if you find the sum of the digits, adding those 3 digits, if the sum is divisible by 3, then the original number is also. And in this case, 1 plus 4 plus 5 is 10, and 10 is not divisible by 3. So 145 is not divisible by 3. And I'll write a few of these down. Not divisible by 2 because 145 is not even. It's not divisible by 3 because 1 plus 4 plus 5 equals 10, and 10 is not divisible by 3. Then we'll check 5, and we have a rule that if the number ends in a 5 or a 0 in the ones place, then it's divisible by 5, and that is true in this case. So we'll look at 145 divided by 5. We'll do some side work over here. Say 145 divided by 5 in this format so that we can do long division. 5 goes into 1 0 times. 5 goes into 14 twice. 2 times 5 is 10. We'll take that 10 away from the 14. That leaves us with 4. Drop down that 5 and we have 45. 45 divided by 5 is 9. 9 times 5 is 45. And 45 minus 45 is 0, so we have no remainder, which is good because that means this is a whole quotient. So we could re-express this relationship this way. 145 equals 5 times 29. And we look at the quotient then and we want to see, is that a number that's prime or is it a number that is composite so that we could break it down into other prime factors? Well, 29 is right here on our list of prime numbers, so 5 is prime, 29 is prime. If you multiply those, you get 145, so we would answer that the prime factors of 145 are 5 and 29. That would be our solution to this problem. We could also have done our work in a factor tree. So some of you have seen this process before, and we did this process this last week, so I know you've seen it, those of you who were there on Friday. So here we go. You make a factor tree this way. You stick the number on the top that you're trying to find the prime factors for, and you divide it by whatever it's divisible by, in this case 5. And 5 times 29 equals 145. So our tree is short in this case because there's only 2 prime numbers, and that's it. But you would maybe need to do your side work still in the same way where you do long division. But in any case, you get this same solution that 145 has prime factors 5 and 29.